Okay, so here is a little intro about what we will call impulse. All right. So one way that we can get to this, all right, is by starting with Newton's second law, okay, F equals ma. And we also know that acceleration is change in velocity over time or change in time, okay? All right, so if we just basically sub in that, we can have this new way to write Newton's second law, which is m delta v over t, or over delta t. Delta t is probably better. Okay, all right, and then if we multiply time to both sides, we get this expression here, okay? And here you can see that is the momentum, okay, or that's going to be the change in momentum because of the delta, okay? And then this side, F delta t, is what we call impulse. Okay, I don't know why my pencil just got a new tip. Okay, and that's going to be symboled by a capital J. Okay, I don't know why. I is already rotational inertia. I have no idea. All right. Okay, so we have a new equation. So we can think of the impulse as the change in momentum. Okay, it could be the change in mass or velocity or both. Okay, or force times time. Okay. All right, and then basically what that means is that in order to change the momentum of something, you have to apply a force, okay? But this one is we apply a force over a certain time, right? Versus, remember, in energy, we apply a force over a certain distance or displacement, okay, to change the energy, okay? So work changes energy, impulse changes momentum. Okay, but as you can see, it's all the same stuff, right? Like you could solve this a gajillion different ways, right? It doesn't even matter. Okay, all right. So this would be a new thing in the problem solving, okay? And what we really want to think about, right, in questions often happen like this, a given change in momentum, like say that the easiest thing to think of is like a car coming to a stop, okay? The mass of the car is the same, and the final and initial velocity of the car is the same. Okay, no matter how it comes to a stop, say it was going 30 miles an hour and then it stops, that's the same no matter what. All right, so in order to make that momentum change happen, I need to apply a certain impulse, all right, which is force times time. Okay, if the stopping time is very big, right, that will make the force very small and be a safer way to stop. Okay, versus if you stop very suddenly and the time is very small, that requires a very big force to get that amount of impulse out. Okay, so that would be like if I stop in 10 seconds, maybe I would only feel a 2 Newton force. Okay, versus if I stop in 2 seconds, I would have to feel a 10 Newton force, right? Because say I needed 20 Newton seconds of impulse. Okay, so the lower you make the time, right, the quicker that change happens, the harder it is on the force, right? Like you would feel it more, I guess I'd say. Okay. All right. So that's a common thing. So this is the idea behind like a water balloon toss, right? When you catch the water balloon, you have to sort of ride it. Or if you catch, like a baseball, you don't just like, boom, stop your hand there. You sort of ride, you kind of move with it. This is the idea behind airbags, right? Anything, a padded wall, any of these things, right? That aren't really about the so-called padding. It's about giving a little more time for that stop to happen. Okay. And it can also be starting, right? Like, but more often those questions are kind of in the stopping. Okay. All right. So that is the new equation. Okay. So impulse is force times time, which is also the change in momentum. Okay. But just notice it's really just a restatement of Newton's second law. Same thing.